Have you ever stopped to think about how companies like Facebook or, even your bank manage the absolutely insane amount of data we all create every single day? Well, for a long time, the answer was a technology called Hadoop. So let's dive in and see how it managed to tame that big data tsunami. I mean, just try to wrap your head around that number. Quintillions. Every tweet, every photo you upload, every single credit card swipe. A single computer, I don't care how powerful it is, would it would melt trying to process all of that. So what's the solution to this massive problem? The real issue here is that trying to store petabytes, and remember, that's thousands of terabytes, on one giant machine just doesn't work. It's way too expensive, and it gives you one single point of failure. If that machine goes down, you're done. So when our old systems hit this wall, we needed a completely new way of thinking. And this right here is the brilliant, almost backwards idea at the very heart of Hadoop. Instead of building one massive, super reliable, and super expensive machine, the philosophy was, what if we just took a huge cluster of normal, cheap, off-the-shelf computers? And here's the crazy part. What if we built the software to expect them to fail? It's literally designed for failure. So if we were to put a textbook definition on it, this is what we get. Hadoop is an open-source framework that lets you store and process gigantic datasets across a whole bunch of regular, everyday computers. The key things to remember here are that it's built to be massively scalable, super fault-tolerant, and, believe it or not, really cost-effective. Okay, so how does it actually pull this off? It really comes down to two main things, what I like to call its two superpowers. They work together. One is for storing all that data, and the other is for processing it. The first superpower is the Hadoop Distributed File System, or HDFS for short. This is the storage part of the equation. Now, don't think of it like a single hard drive. Think of it more like a magical, infinitely expandable library, where all the books are spread out across thousands and thousands of shelves. So how in the world does HDFS handle these enormous files? Well, it doesn't try to store them in one big piece. Instead, it takes a massive file, like this 400 megabyte one here, and it just chops it up into smaller, perfectly uniform blocks. Then it scatters those blocks across all the different computers in the cluster. And the standard size for just one of these blocks? A whopping 128 megabytes. Now that might sound absolutely huge for a single block, but trust me, there's a really good reason for it. Let's put that number into perspective, right? The file system on your laptop probably uses tiny little blocks, something like 4 kilobytes. HDFS uses these massive blocks because when you're dealing with files that are petabytes in size, having fewer, bigger blocks to keep track of makes managing everything so much simpler. It just cuts down on all the bookkeeping, and it's all about optimizing for incredible scale. But hang on a second. You might be thinking, what happens if one of those cheap computers just dies and takes my data block with it? This is where the real genius of Hadoop shines through. It makes copies. By default, every single block is replicated 3 times and then stored on different machines across the cluster. This way, you're pretty much guaranteed to never lose any data. So how is all this organized? It's what's called a master-slave system. You have one main computer, the name node, that's the master. Think of it like the head librarian. It has the master map and knows exactly where every single block of every single file is. Then you have hundreds, maybe thousands, of data nodes. Those are the slaves, and they do the actual grunt work of storing the data blocks. Okay, so we've got our data safely stored across thousands of machines. Fantastic. But now, how do we actually do anything with it? Well, that brings us to superpower number 2, MapReduce. This is the processing engine. It's like having a whole army of workers who can all tackle one small piece of a giant puzzle at the exact same time. Here's the big picture of how it works. The map phase is where you take a huge problem and you break it down into much smaller pieces that can be worked on at the same time, right on the machines where the data already lives. Then the reduced phase comes in, takes all the individual answers from the mappers, and combines them all into one final result. So if we put it all together, we get this really elegant 6-step flow. First, data gets loaded into HDFS and split up. Then you submit a job. That job gets broken up into a bunch of map tasks that all run in parallel. The results from those tasks get gathered up and aggregated by the reduced tasks, and then the final output gets saved right back where it started, in HDFS. It's a really powerful and massively parallel system. Okay, this all sounds great in theory, but where is Hadoop actually being used out in the wild? Why did this technology become such a big deal? The simple answer is pretty much everywhere. Banks are using it to spot fraudulent transactions in real time.
Retailers use it to analyze your shopping habits to figure out what to sell you next. Social media platforms, of course, use it to figure out trends and what you want to see in your feed. From healthcare to telecommunications, Hadoop really became the backbone for making sense of enormous data sets.
Now, it's also really important to understand that Hadoop isn't just this one single thing. It's actually the foundation of a whole ecosystem of tools. You've got things like Spark, which can process data even faster than MapReduce, or Hive, which lets analysts query all this data using SQL commands they already know. They're all built to work right on top of Hadoop's core storage. But, technology never, ever stands still. Hadoop's been around for a while now, and it has evolved a ton over the years, becoming way more efficient and a lot more capable. Just look at the jump from version 2 to version 3. It reveals some major upgrades. Hadoop 3 brought in something called erasure coding, which is a much smarter way to protect data. It gives you the same level of safety as making 3 full copies, but uses about 50% less storage space, which is huge. It also added support for modern tools, like using GPUs for heavy-duty machine learning and Docker for deploying apps more easily. That's what's kept it relevant for today's AI workloads. So when you boil it all down, Hadoop's core ideas, this whole concept of distributed storage and parallel processing on cheap hardware, they really did kickstart the big data revolution. It paved the way for so many of the technologies we just take for granted today. And as that data tsunami just keeps getting bigger, it leaves us with a really fascinating question. What comes next?